In this video we're going to look at a diaphragm valve. I'm going to explain to you how it works, we'll look at some of the main components, and then we'll look at some of the diaphragm valve's advantages and disadvantages along with some of its applications. So let's do a quick spin. You can see the one side of the diaphragm and how we would normally see it when it's installed. You can also see here that we've got an indicator for flow. That means that the inlet is here and the outlet is on the opposite side. This type of valve is used for open, closed and throttling applications. We can see that the valve is being actuated now. It's moving up and down in a vertical direction. And if we zoom in, we can have a look at the diaphragm, which is where the diaphragm valve gets its name. You can see the diaphragm being pulled up now. The valve is in the open position. The diaphragm is now pressed downwards and the diaphragm is in the closed position. Okay, so we've got the compressor, which is this item here, and that is what we're using to lower and raise the diaphragm. The diaphragm is actually quite flexible. It's going to be made of some form of polymer material, perhaps a rubber type material or something quite similar. It has to be flexible because it's going to be lowered and raised down by the compressor, and it needs to be able to withstand potentially frequent operation. If we go upwards, we can actually see a piston, that is the blue area here, and the piston is used to press down on the compressor and also to lift the compressor back up again. We've actually got two yellow connections on the side of the valve. These are connections to a compressed air system, and we will either add compressed air to the top or the bottom, and this is going to push the piston up or down. On the top of the valve we've got an indicator or a position indicator, and this indicates to us now that the valve is open and now it is closed. Press pause, we can see the O-ring, which is used for sealing, and another O-ring which is also used for sealing to stop the air on the top passing through and going to the underside of the piston. The largest advantage with this type of valve is that it can be used for corrosive systems. Because the diaphragm is not metal, it will be made from, for example, a rubber-like material, and because the valve body itself is also made from a polymer or plastic material, it can be used within systems where metal may react with a certain liquid or a gas, and in order to get around this problem we will use a plastic body and the rubber-like material for the diaphragm. If we zoom in now, I'll pause the animation, we can see that if we were flowing through the valve, such as we are doing now, we will encounter only the body and the diaphragm. So there is the outlet. I'll zoom back out. The body is here and the diaphragm, and the body is on the opposite side, and those are the only two parts of the valve that we will come into contact with. This is a huge advantage if the flowing medium is very corrosive or perhaps is toxic, because fewer parts means a lower probability that we will have a leak. There are simply not as many seals, so there are not as many places where we can have leaks. And we also have the advantage that contaminants cannot get into the system. Perhaps we have a flowing gas that has to be incredibly clean and cannot tolerate anything more than 1 part per billion of dust or foreign particles. And in this instance we can use a diaphragm valve because the probability that we will get ambient air going into the system or that we will get a leak is very low. So this is a huge advantage with this type of valve. The disadvantage with this type of valve, and this is common for a lot of elastomer materials such as the diaphragm or plastic materials such as the body, is that the materials become quite soft or malleable at higher temperatures, and if they're not soft and malleable they may even become quite brittle. If it becomes brittle, it means that as it's lowered and raised it will crack, and then we will get leaking or passing through the valve.